Pakistan to present the LUMS mine detector project. So firstly, to introduce myself, so I was born and raised in Pakistan. I did my bachelor's in mechatronics engineering, and I'm a graduate student of computer engineering, both in Pakistan. I'm associated with the Laboratory of Cyber Physical Networks and Systems in LUMS, directed and founded by Dr. Muhammad. LUMS is a privately owned university which was initially started as a business and management school in 1985. But eventually they established the School of Science and Engineering in 2008. It's a small-sized university with around a 2,300 student body and a 100-acre campus. So to really start with the issue, you must be aware of the military situation in Pakistan, and among the many problems being faced today by the locals is that of unexploded landmines. So the landmines claim many innocent lives every year, and they continue to remain a threat even after the conflicts are over. And in the floods of 2010, the situation worsened because the floods carried the landmines from the affected areas to other zones. So addressing this issue in 2010, National Instruments Arabia Division announced the National Instruments Mine Detection Robot Design Contest. And seizing this opportunity, LUMS sent an entry, and after multiple phases with field trials held in Beirut, Lebanon, the LUMS entry won with an award in the vision and minesweeping algorithms. So the team that worked on this project comes from 2 laboratories at LUMS. It includes faculty members, students, technicians, and staff. So one of the very first dilemmas that we faced while trying to develop such a project in a third world country was that we really wanted to implement the complex solutions that work, but unfortunately we did not have funds to match. The alternative, on the other hand, was the simple solutions, which cost less but do not have a very high chance of success. So our answer to this was a cheap platform replicated many times over. So instead of developing a single complex and very costly robot, we proposed to develop multiple low-cost and scalable robots. So in the picture here you can see our lead mine vehicle, Marwa, and you can see Duldul, a scout-like robot which can traverse terrains that Marwa cannot. You can see Hanum, a telepresence machine used for indoor proof of concept testing only, and Safa, a laboratory test bed for robot group coordination algorithms. So to actually achieve what we wanted, our approach had to match our objectives. Developing countries like Pakistan do not have a lot of advanced machining capabilities. So in order to make an average craftsman be able to assemble the robot, we needed a mechanical design that was replicable and portable. And following similar constraints, we decided to opt for open source platforms over commercial ones. And instead of the costly laser scanners and similar sensors, we used new and cheap vision sensors. And all of this was done without compromising the total effectiveness of a mine detection solution. And for rapid prototyping, we used equipment awarded by National Instruments under the PlanetNI umbrella, which allowed us to test our ideas in a quick and more flexible manner. So once we started developing this project, we realized that due to lack of funds and other budget constraints, we were not able to actually purchase our sensors and actuators from commercial sources. So we scoured and salvaged scrap yards to save spare parts, and actually the mine detection sensor that we used in the final field trials were bought from our toy store. So after we got all the spare parts, the machining was also a challenge for us, because while in developed countries, computer numerically controlled machines are affordable and easily available, we have to rely on machines that are operated manually and by less qualified people. And once the machine was delivered to us, we set up a So we set up an experimentation test bed in a laboratory and conducted local experiments to test our software and mechanics. So in this picture you can see a shot of our lead vehicle Marva in midway between its completion and also in its final form. The robot is equipped with a Microsoft Kinect sensor and a stereo camera pair, and it has a metal detector sensor mounted on the front of its arm, and that is how mines are actually detected. It's a four-wheel drive system and it's actuated by the motors that we salvage from the power window systems of automobiles. And it shows 2 onboard computers, which we plan to cut down to 1 in the near future. And the impact of this project has been manifold. We've had incredible hands-on experience in working with vision sensors and their algorithms. Our research has been published in multiple conferences, and we've gained valuable hands-on experience. We've got our hands really dirty in this project while doing this stuff. And not only has this given us several advantages as an institution, but we've also received international recognition for this work. This has sparked a collaboration with a research group in Germany for development of agriculture and demining robots. And also the group has gained valuable international exposure from their travel to Beirut and in Austin. And the most important impact in my view would be a step taken towards an automated solution to the demining problem. We admit that there is still a very long way to go for a complete robotic solution, but significant progress can be made for now by solving individual problems and making efforts such as these. So I'd like to acknowledge our sponsors, National Instruments Arabia Division, who provided valuable equipment and traveling and lodging to Beirut and Austin, and also our point of contact, Ali Kubesi, who was really incredible through all this period. And also funding was provided by our university, our department, and I'd also like to acknowledge our machinists and local collaborators. And in the end, I thank you all for your attention.